Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook, this one reverse percentage slip cost a student 2 marks on last year's paper. They subtracted 20% instead of undoing a 20% increase. It looks small, but in a tight exam, every mark counts. Stick with me, and I'll give you a one-line routine so you never make that mistake again.
Sound familiar? I remember thinking, just take 20% off, which is exactly where I went wrong. Show me the simple rule.
The concept. Start with the single idea you must remember. Percentages act multiplicatively. If an original price P is increased by 20%, the new price is 1.2 times P. That 1.2 is the multiplicative factor, 1 plus the percentage as a decimal. Algebra makes this obvious. If the original price is P and it increases by 20%, then new equals P multiplied by 1 plus 20 over 100 equals 1.2P. So to find the original, you don't subtract 20%, you divide the new price by 1.2. That inversion is the algebraic step examiners want to see.
Okay, so divide instead of subtract. Can we do a quick example?
Example 1. An item costs £90 after a 20% increase. What was the original price? Set it up. 90 equals 1.2 times P. Now rearrange. P equals 90 divided by 1.2. On a calculator, that gives P equals £75. Write the equation, divide, and give the unit. That final £75 is the answer you hand in.
That feels neat. What about a decrease? I once tried to reverse a 15% discount and felt lost.
Example 2. If a price ends up at £85 after a 15% decrease, the multiplicative factor is 1 minus 15 over 100 equals 0.85. So 85 equals 0.85 times P, and P equals 85 divided by 0.85 equals 100. Same algebra, same inversion, different factor. The rule is universal. Write to factor, then divide.
Quick note on successive changes. Percentages multiply. Increase 10%, then decrease 20% gives a total factor of 1.1 times 0.8 equals 0.88. It isn't zero change, and increases and decreases do not cancel each other. If you need to undo successive changes, divide by the product of the factors.
So, rather than memorizing lots of tiny tricks, I just write the factors and use algebra.
Exactly. Algebra beats rote memory every time. Now let's map that method to exam marks so you know what examiners are looking for.
The exam technique. For a typical 3-mark reverse percentage question, the marks usually break down like this. M1 for setting up the correct equation, for example, 90 equals 1.2p, M1 for the correct algebraic manipulation, rearranging to P equals 90 divided by 1.2, and A1 for the final correct answer with the unit, and ideally a short check. Write the equation. That's a mark, even if you can't finish the arithmetic.
What are the common mistakes that actually lose those marks?
Common pitfalls. Students subtract the percentage instead of dividing. They use the wrong factor, mixing up 1.2 and 0.8, for example. They don't show the inversion step, so the examiner can't award method marks. And they round too early or forget units. Any of those cost you marks you could have easily taken.
Also, watch out for calculator order of operations slips. If you calculate successive factors, use brackets or multiply the factors first, then divide once. Keep your working linear and readable. 90 equals 1.2p, p equals 90 divided by 1.2 is perfect.
Give me the 10-second routine I can use in every question. I want something automatic.
The quick win. 3 quick steps. Write the multiplicative factor, divide the final amount by that factor. Check by multiplying your answer by the factor to see if you get the final amount. In practice, write 1 plus percentage or 1 minus percentage, convert to decimal, divide, then substitute back. Round only at the end. Calculator tip. Avoid percentage buttons when reversing. Type the final number, divide factor. For example, 90 divided by 1.2. For successive changes, multiply the factors first, then divide once. That prevents rounding drift.
Ha! I can do that in 10 seconds. One line check, that's the key, right?
Exactly. Now a short outro and a clear call to action. That's your one-sentence recap. Write the factor, divide, and check. If you want more worked examples and a downloadable worksheet with practice questions, visit jcacademyonline.co.uk. Visit the show notes for the link.
Bonus Practice Challenge. 3 short prompts for you to try now. I'll give minimal working to earn marks and the answers so you can check quickly. Challenge 1. An item costs £132 after a 10% increase. Find the original price. Setup. 132 equals 1.10 times P, so P equals 132 divided by 1.10 equals £120. Marks. M1 for equation, M1 for division, A1 for £120 with units. Challenge 2. A jacket is £51 after a 15% discount. Find the original price. Setup. 51 equals 0.85 times P, so P equals 51 divided by 0.85 equals £60. Quick check. 60 times 0.85 equals 51. Challenge 3. A gadget first increases by 20%, then by a further 10%, and ends up at £792. What was the original? Multiply factors. 1.2 times 1.1 equals 1.32. So 792 equals 1.32 times P, and P equals 792 divided by 1.32 equals £600. That demonstrates successive changes clearly.
Those were quick to check. Doing the setup gives me confidence I won't lose the method marks if I run out of time.
Final recap and sign off. Remember the single principle. Percentages use multiplicative factors. Write the factor, divide to undo, and always substitute back as a one-line check. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.